Hello everyone, welcome back to my YouTube channel. Let's encode the logic. I hope you all are doing good. In this video, we are going to discuss about some coding problems which are using for loop and while loop, guys. And these are the famous coding problems which are asked by the interviewers during interviews, guys. And in this video, at first I will explain you the logic and then we will delve into the coding part. So it might be time taking, but trust me guys, this is the best video for you. And I will highly recommend to the beginners who want to enter into the coding world. And one more thing, this is the part 2 of coding series using for loop and while loop, guys. So if you haven't watched the part 1 series, I will provide the link in the description box. Please do check it and watch it, guys. And without making any delay, let's quickly start our part 2 coding series. In this video, we are going to discuss about a program that was Fibonacci sequence. This program is very, very important during interviews, guys, because this program has the more chances to ask by the interviewers. What is a Fibonacci sequence? The Fibonacci sequence is a series of numbers where each number is the sum of two preceding ones, usually starting with 0 and 1. So the sequence goes like this: 0, 1, 1, 2, 3, 5, 8, 13, 21, and so on with each subsequent number being the sum of the previous two numbers. So if you see, the Fibonacci sequence will start from 0 and 1. Okay, let's keep that. And later, with each subsequent number being the sum of previous two numbers. So in the Fibonacci sequence, the first term is 0 and the second term is 1. And the third term will be the sum of previous two numbers. So the sum of 0 plus 1 is 1. And the fourth term was sum of its previous. That was 1 plus 1. It was 2. And the fifth term was sum of its previous. That was 1 plus 2. It was 3. And the sixth term was 3 plus 2. It was 5. And the next term was 3 plus 5. That was 8. And 5 plus 8. It was 13. And 8 plus 13. It was 21. It will keep on going. Right? There is no stop to this Fibonacci sequence. Now we need to write a code for this Fibonacci sequence. Now the question was how we can write a code for a problem which will keep on going. There is no stop for it, right? So what we will do is, for example, if you see Fibonacci sequence up to 5 terms. For suppose if the user will enter 5, then you need to print the first 5 terms in the Fibonacci sequence. And if the user will enter 10, then you need to print the first 10 terms in the Fibonacci sequence. So in this way, we need to write the code. We won't go beyond the limit. So within the limit, we will write a code. Let's write the code for it. So before diving into the coding part, let's figure out the logic in the simple words. At first, we need to take the input. So what could be my input? My input was n. So I need to mention number of terms, right? Now coming to the logic part, I want to use a for loop because if you observe, this is the first term and this is the second term and this is the third term and this is the fourth term, fifth term, sixth term. For suppose if the user asks you to print the first 5 terms, then you will go from 0 to 3, right? You will print the first term and then the second term and then the third term, fourth term, fifth term. You are following a sequence, right? So that's why I will use a for loop. And while iterating on the for loop, I will print the terms. So this is my logic. Now let's write the code for it. Okay, let me keep it coming first. That was Fibonacci sequence program, right? Okay, now I need to take the input. So my input was n, right? So n equal to int of input of enter number of terms, right? Now, if you see, my Fibonacci sequence will starts from 0 and then 1. They are already defined, right? So we need to define them in our code also. I will keep f1 equal to 0 and f2 equal to 1. Okay. And also, these are my first and second terms, right? So I need to print them, right? So, okay, let me print them. So print f1, comma, f2, comma, and equal to. I will use an and equal to because I kept this because I want to print the remaining terms within the same line. Okay. Now I will use a for loop for the remaining terms. So for I in range of. So what could be my range? So this is my first term and this is my second term. So I need to print from the third term, right? And I need to go till nth term, right? So my range was 3 comma n plus 1. Now what I need to do? I need to print the remaining terms, right? So how could I print this term? I will add the previous two terms, right? Okay, let's do that. I will add f1 plus f2. Let me store it another variable that was f3. f3 equal to f1 plus f2. Nice. What should I do? I need to print the f3, right? Okay, let me do that. I will keep end equal to, okay. Okay, now let's trace the code. So at first I will print 0 and 1, and then I will do f3 equal to 0 plus 1. Then my f3 will become 1, right? And then I will print f3. And again, I will go to the second iteration. And again, I will do f1 plus f2. And again, in the second iteration also, my f3 will become 1. In the third iteration also, it will become 1. And then in the fourth iteration also, it will become 1. So my output was like 1, 1, 1. But I want my output as 0, 1, 1, 2, 3, right? So I need to add something in my code. Okay, let's figure out what was happening. Okay, let's take a series of items. That was 1, and then 2, and then 3, right? In my first iteration, what was happening? This was f1, and this was f2, and this was f3, right? So I will do f3 equal to f1 plus f2. Then I got 1. Okay, working fine. Now to get the fourth term, that was 2, what I need to do? I need to make this one as f1 and this one as f2, right? So I will make this as f1 and this as f2, and I will print f1 plus f2. That was 2, right? And to get this fifth term, that was 3, what I need to do? I need to make this as f1 and this as f2, right? Okay, let me do that. Then this was f1 and this was f2, and f3 equal to 1 plus 2, that was 3, right? Now, every time what I was doing, I was changing my f1 and f2 variables, right? I was changing them. So, how I was changing them? Now, let's go back and see again. In order to get my fifth term, that was 3, what I need to do? I need to make f2 as f1 and f3 as f2, right? Then only we will get the f3. So, this is the simple change that we need to do in our logic. Okay, what was that change? We are making f2 equal to f3 and f1 equal to f2. Simple, right? Okay, let's include that in our code. We are making f2 equal to f3 and f1 equal to f2. We are keeping the upcoming term, right? For the f2, the upcoming term was f3, and for the f1, the upcoming term was f2, right? We are just keeping the upcoming terms in them. Now, if I change my variables like this, so what happens? I was storing the value of f3 in f2, right? Okay. Let me understand this for you in pictorial representation. Okay. So this was f2 and I was storing the value of f3, right? Now my f2 was storing f3. Okay, fine. And I was storing the value of f2 in f1, right? So I was storing f2 in f1, right? So what was my f2? My f2 was f3, right? So what happening? Both f2 and f1 was storing f3 itself. Then this is not the proper way of changing the variables, right? But this is the correct way only. But we need to do a little bit of modification in our code. That was, before changing f2 equal to f3, we need to change f1 equal to f2 first. Then we need to change f2 equal to f3. Okay, let's change it and we'll see. Okay, let me remove this. And let's write f1 equal to f2 and f2 equal to f3, right? Now let's see. I was storing the value of f2 in f1, right? Okay. So this is the f1 and I was storing f2. Okay, fine. And I was storing the value of f3 in f2, right? So this is the f2 and this was f3, right? Now this is working perfectly, right? Now the f1 was storing f2 and the f2 was storing f3. That is what we want. Now let's trace the code. Let us say I want to go till 5 terms. At first I will print 0 and 1, and then in the first iteration, that was when I equal to 3, my f3 will become f1 plus f2. That was 0 plus 1, which is equal to 1. And then my f1 will become f2, nothing but 1. My f2 will become f3, which is equal to 1. Okay. And in the second iteration, nothing but when I equal to 4, right? my F3 will become F1 plus F2. So we will do 1 plus 1, which is equal to 2. And my F1 will become F2. F2 was 1, right? And my F2 will become F3, which is equal to 2. So F2 will become 2. Okay. And in the third iteration, nothing but when I equal to 5, my F3 will become F1 plus F2. That was 3. And I will print that. Later my F1 will become F2, which is 2. And F2 will become 3. So in this way, the program will work. Now let me run this program and we'll see. So I will give 5. So it was 0, 1, 1, 3. Okay, let me run this program again. And this time I'll give 10. So if you see 0, 1, 1, 2, 3, 2 plus 3, 5, 3 plus 5, 8, 5 plus 8, 13, 8 plus 13, 21, and 21 plus 13, 34. Okay, working fine. Okay, let me run this program again. So I will give 0. So it was giving me 0 and 1. Why it was giving me like that? It shouldn't, right? Okay, let me give 1 this time. So it was again giving me 0 and 1. So my program should needs to print 0 only when my number of terms was 1. So now again I need to change my code, right? Okay, what I will do is I will use a if else statement. If n equal to 1, I will print f1 comma n equal to elif n equal to 2, then I will print f1 comma f2, right? Or else means when my n is 3, 4, 5, right? Then every time I need to print this for sure, right? Okay, let me print that. And also I need to go through this iteration, right? Okay, now let me run this program again. So I will give 1. So it has given me only 0. Okay, fine. And let me run this program again. I will give 2. So it was giving me 0 and 1. Okay, let me run this program again. I will give 5. Okay, 0, 1, 1, 2, 3. Okay, working fine. And one more thing, there is no need to keep this statement, because if n equal to 1, it will print 0. Or else, if n equal to 2, then it will print 0 and 1. And this for loop will not going to be executed because my n was 2 and my range was 3, 3, which doesn't make any sense, right? So this for loop will not execute it. Okay, now let me run this program and we'll again see. So if it is 2, okay, it was giving me 0 and 1. Fine. And let me run this program again. So I will give 6 this time. So if you see 0, 1, 1, 2, 3, 5. So in this way, we will write a Fibonacci sequence program using for loop, guys. Now we need to write the same program using the while loop, right? Okay, let me remove this for part. So from where should I need to start my iteration? I need to start my iteration from 3, right? And while I less than or equal to n, I will do f3 equal to f1 plus f2. And I will print f3 command equal to space. And I will make f1 equal to f2 and f2 equal to f3, right? And also I need to increment my I value, right? I will do I equal to I plus 1. So this is the code. Let me run this program. So I will give 20. So these are the first 20 terms in the Fibonacci sequence, right? And let me run this program again. I will give 2. So if you see, it was 0 and 1. Okay, working fine. I will give 3. So 0, 1, 1, working fine. And I will give 9. So the first 9 terms. So these are the first 9 terms. So in this way, we will write the Fibonacci sequence program using while loop. In this video, we are going to discuss about a program that was sum of digits in a number. Let us say if n equal to 123, then sum of digits equal to 1 plus 2 plus 3, which is equal to 6. If n equal to 92,538, then sum of digits is 9 plus 2 plus 5 plus 3 plus 8, which is equal to 27. Okay, if n equal to 1000, then sum of digits equal to 1 plus 0 plus 0 plus 0, which is equal to 1. So we need to write a program to find out the sum of digits of a number. So what we are doing in a number, we are extracting the digits and we are adding them, right? If you see in 123, we are extracted 1 and then 2 and then 3 and then we added them, right? So what we need to do, we need to extract the digits. Now the question was how we can extract the digits. Okay, now let's see the logic for this. Let us say I have a number which is equal to 123. Okay. Now in this number, we can extract the last digit very easily. Okay, let's do n mod 10, which is equal to 123 mod 10, right? Okay, let's do that. So 10 12s are 120, right? Now my remainder was 3. Now if you see, I got my last digit, right? Which is equal to 3. Both are same, right? So if you do n mod 10, you will get last digit very easily. So now how to get the second last digit? Nothing but this 2. If you observe the quotient of 123 mod 10, that was 12, right? Which is the remaining number, right? That was 12. Now what we need to do? We need to do 12 mod 10. Okay, let's do that. 10 and then 12. So 10 ones are 10, right? So the remainder is, now if you observe, the remainder of 12 mod 10 is equal to the second last digit, right? Now we extracted 2 also. If you observe, the quotient of 12 mod 10, that was 1, right? Which is the remaining part. Now we will again do 1 mod 10, right? Okay, let's do that. 10 1 0. So which is equal to 0, and this was 0, and the remainder was 1, right? So now if you observe, which is the third last digit, right? That was 1. Now the 1 is also extracted. Now what we need to do? We need to add all these numbers, right? We will do 3 plus 2 plus 1, which is equal to 6. So this is the logic. Now we will get the reminders by doing n mod 10, right? And we will get the quotient by doing n by 10, right? Now let's write the code for it. So before diving into the coding part, let's figure out the logic in simple words. At first, we need to take the input. The input was n, right? Later, the logic part. So what we are doing? We are extracting the numbers. So for that, we are iterating till number of digits. So if you see, if n equal to 123, we iterated 3 times, right? If n equal to 92,538, then we will iterate for 5 times. And also in the first iteration, my n will become 123. And in the second iteration, my n will become 12. And in the third iteration, my n will become 1. And in the fourth iteration, my n will become 0, right? While iterating on the number, we will implement this logic. Since we are iterating on a number, we need to use loops. And we have for loop and while loop. And for the for loop, we need to have a sequence, right? If you observe, is there any sequence that we have? No, right? So we can't use a for loop to implement this. So we can use a while loop. And coming to the printing part, while iterating on the number, we will add all these reminders to a variable. And finally, we will print that variable after the iterations. Okay, now let's write the code for it. Let me keep a comment first. Right, now we need to take the input. That was n equal to int of input of enter a number. Later, we need to use a while loop, right? Okay, let's figure out the condition later. Let's focus on the logic part. So what we are doing? We are finding out the remainder when n is divisible by 10, right? Remainder equal to n mod 10, right? Later, what we need to do? We need to add that remainder to a variable, right? So let's take answer and we need to initialize the answer equal to 0 because we are adding the remainder to answer, right? That's why we need to initialize the answer as 0. And then answer equal to answer plus reminder, right? And then what we are doing? We are making the quotient as n, right? In the first iteration, my n was 123. In the second iteration, my n was 12. Nothing but the quotient, right? How we find out the quotient? We will do n by 10, right? So quotient equal to n by 10, right? And what we are doing? We are making that quotient as n, right? So n equal to quotient, right? So instead of writing in these two lines, we can write n equal to n by 10. Now what we are doing with this n? We are again performing modulo of 10, right? So again, we will perform n mod 10. And with that reminder, we will append that to answer, right? And again, we will make this quotient as n. So that is what repeating. So this is the while block logic. Now we need to figure out the while condition. Where does the while loop needs to go till? So if you observe, in the third iteration, my n equal to 1, and then we performed n mod 10, and my remainder was 1, and later my quotient was 0. And in the fourth iteration, my n has become 0, right? And then there is no need to go for further iterations, right? When my n will become 0, I need to stop iterating, right? My condition will be if n not equal to 0. So this is the condition. So at first I will check, is 123 is not equal to 0? Yes, it was true. 123 is not equal to 0, right? Then it will go through this block. And then my n will become 12. Is 12 not equal to 0? Yes, it's true. Then again this block will be executed. And then I will check, is 1 not equal to 0? Yes, it's true. And then my n will become 0, right? I will check, is 0 not equal to 0? It was false, right? Then I will stop iterating on the loop. So this is the logic part. Now we need to print the answer, right? Let's print that. Print sum of digits equal to answer. And one more thing, in Python, we need to do float division to get the precise value. So this is the code. Let me run the program and we'll see the output. Okay, I will give 123. So sum of digits equal to 6, right? Okay, let me run this program again. I will give 925 and then 37. So which is equal to 26. Okay, let me run this program again. So this time I will give 0, 0, 1, 2, 3, 4. So 1 plus 1 plus 2 plus 3 plus 4, which is equal to 11, right? So if you see, sum of digits equal to 11. Okay, working fine. Okay, let us say I want to print my number like sum of digits of number is. Okay, let me run this program and we'll see the output. So if you see, sum of digits of 0 is 6, but I want my output be like sum of digits of 123 is 6. To get that, let's restore the value of n in num in some other variable, and we'll do sum of digits of num is answer. Okay, now let's run this program. Now let's give 123. So if you see, sum of digits of 123 is 6. So this is the standard way of writing sum of digits in a number program, guys. In this video, we are going to discuss about a program to check whether a number is a Harshad number or not. So what is a Harshad number? A number is said to be a Harshad number if it is divisible by sum of its digits. And Harshad number is also known as even number. So a number is said to be a Harshad number if it is divisible by sum of its digits. Right. For example, 18 is a Harshad number. So what is the sum of its digits? It was 1 plus 8, which is equal to 9, right? And if we perform 18 mod 9, then we will get remainder as 0, right? Because 9 is divisible by 18. So that's why 18 is a Harshad number. And 15 is not a Harshad number because what is the result of sum of its digits in 15? It was 1 plus 5, which is equal to 6, right? So if I do 15 mod 6, is it divisible? No, right? If I do 15 mod 6, then I will get the remainder as 3, not 0, right? So that's why 15 is not a Harshad number. Simple. So now we need to write a program to check whether a number is a Harshad number or not. We can easily check whether a number is divisible by some other number or not, right? So there is no problem for it. But coming to sum of the digits of a number, we need to know how to write a code for it. I have already made a video on finding the sum of digits of a number, guys. If you haven't watched that video yet, please do watch it. I will provide the link in the description box, so please do check it. Again, in this video, I will explain the concept of how to find out sum of digits of a number. So let's take a number 123. So what we need? We need the digits, right? For that, we need to extract the digits from a number. So now the question is how to extract the digits from a number. It is very simple. We can extract the last digit of this number, that was 3, very easily. So if we perform 123 mod 10, then we can get the last digit very easily. So let's do that. So 10 12s are 120. Right. Now the remainder was 3. I got my last digit. Okay, fine. Now I need to get my second last digit. Right. And if you observe, the quotient of 123 divided by 10 was 12, which is the remaining part. Right. So take this quotient, and to get the second last digit, just do 12 mod 10. So if you do 10 and then 12, so 10 ones are 10, right? And the remainder was 2, right? So we got the second last digit also. Now we need to get the third last digit, right? And if you observe the quotient of 12 divided by 10, it was 1, which is the remaining number, right? So this time again take this and just do 1 mod 10. And if you do 10 divided by 1, 10 zeros are 0, and my remainder was 1. So we got the third last digit also. Simple. So for the reminders, we will do n mod 10, and for the quotient, we will do n by 10, right? And one more thing, in the first iteration, my n was 123. And in the second iteration, the quotient of the previous iteration is the n, right? And in the third iteration, my n was the previous iteration quotient, right? So in this way, we will extract the digits from the number. So now we need to write the code for it. So before diving into the coding part, let's figure out the logic in simple words. At first, we have to take the input, that was simple n. And coming to the logic part, we will use a while loop, and we will iterate on the number to extract the digits. So we will implement this logic. Okay. And while iterating, we will add all these reminders to a variable. After completion of the iterations, we will check if the number is divisible by sum of its digits or not. For that, we will use an if-else statement. If it is divisible, then we will print the number is a Harshad number. If it is not divisible, we will print the number is not a Harshad number. Simple. So now let's write the code for it. Let me keep a comment first. Check if a number is Harshad number. At first, we have to take the input. N equal to int of input of enter a number, right? Later, I will use a while loop. So let's figure out the while loop condition later. Let's focus on the logic part. So at first, what we need to do? We need to extract the digits, right? For that, we need to find out the remainder, right? That was n mod 10. Okay, let's do that. N mod 10. And I will store the result in some variable. Let us take the variable as remainder equal to, right? And then what I need to do? I need to add that remainder to some variable, right? So let's take that variable as answer variable and initialize it to 0. I initialized answer equal to 0 because I was adding some values to answer variable. So for that purpose only, I initialized my variable as 0. Now what I need to do? I need to add the remainder to answer variable, right? So answer plus equal to remainder, which is also similar to answer equal to answer plus remainder. Both are same. And now what I need to do? I need to change my n to the previous iteration quotient, right? So to get the previous iteration quotient, I will do n by 10. And I again making this as n, right? N equal to n by 10. and I will use a float division to get the precise value, right? So now coming to the while condition. So where do we need to stop the iterations? Once all the digits in the number was completed, right? So if you observe, this is the first iteration and this is the second iteration and the third iteration. And in the fourth iteration, what is my n? My n value was 0, right? So this will act as a terminating condition, right? So I need to mention while n not equal to 0. So every time I will check, is my number is not equal to 0 or not? If it is true, then this block of code will be executed. Once my n will become 0, I will check, is 0 not equal to 0? No, right? Then automatically this block will not going to be executed and will come to this next line after the while loop. So now what do I need to do? I need to check whether the number is divisible by answer or not, sum of its digits or not, right? So for that I will use an if else statement. I will do if n mod answer equal to 0 or not. If you write the statement like this, then it will be a blunder mistake, guys, because after the iterations, what was my n? My n will become 0, right? That's why I kept this as my terminating condition. So then how do I need to get my actual n value? Simple. You just need to restore the value of n. So I will use a num variable and I will store n. Simple. Now I will keep my condition as if num mod answer equal to 0 or not. If it is divisible, then I will print number is a Harshad number, right? So num is a Harshad number. Or else I will print num is not a Harshad number, right? Simple. So now let's run this program. So I will enter 18. So if you see 18 is a Harshad number, right? And I will enter 15. So 15 is not a Harshad number, right? I'll again run this program. So I will give 300. 300 is a Harshad number. If you sum the digits in 300, then you will get 3. Is 300 divisible by 3? Yes, it's true, right? So that's why 300 is a Harshad number. And let me run this program again. I will enter 29. If you see 29 is not a Harshad number because 2 plus 9, which was 11. Is 29 is divisible by 11? No, right? That's why 29 is not a Harshad number. So in this way, we will write a program to check whether a number is a Harshad number or not, guys. In this video, we are going to discuss about a program to count number of digits in a number. So we need to find out the number of digits in a number. If n equal to 123, then the number of digits in 123 is 3, right? If n equal to 7,86,543, then the number of digits in this number is 6, right? So now we need to write a program to find out number of digits in a number. So it's a very simple logic. Let's see that. So let's take the number 123. What we need to do? We need to count the number of digits, right? So for that, what we can do? We can extract these digits, right? We can extract like 1 and 2 and then 3. We can separate them, right? So once we separate them, we can easily count them, right? So how we can separate them? So there is a logic to extract these digits. Let's see that. Okay, let's perform n mod 10. This is nothing but 123 mod 10, right? And then 123 and 10 12s are 120, right? And now my remainder was 3, right? So if you see, we extracted last digit, right? And now we need to extract the remaining digits also, right? And if you observe the quotient of this 123 divided by 10, that was the remaining number, right? So take this quotient and to get the second last digit, perform 12 mod 10. If you do this, 10 and then 12 and then 10 ones are 10, right? And my remainder was 2. And if you observe, we extracted the 2 also, right? If you observe the quotient, which is the remaining number, right? Now, using this quotient, let's do 1 mod 10. So, it was 10 and 1 and 10 zeros are 0. And if you see, my remainder was 1. So, we extracted this one also, right? And now if you observe, my quotient was 0, nothing. Before 123, we had 0, right? Which is no use. So how we are extracting the digits? We are simply finding out the reminders, right? How? Doing n mod 10. And the quotient was n by 10, right? And one more thing, this is the first iteration, and this is the second iteration, and this is the third iterations. So if we count number of iterations, then it will be the number of digits, right? Number of iterations will be the number of digits, right? And one more thing, in the first iteration, my n was 123. And in the second iteration, I was making my previous iteration quotient as n, right? And in the third iteration, I was making my previous iteration quotient, that was 1, as my n, right? So every time my n was changing through the iterations. So now we need to write the code for it. So before diving into the coding part, let's figure out the logic in simple words. At first, we need to take the input. So what is my input? That was n, right? And then coming to the logic part, I will use a while loop. So using while loop, I will extract these digits. So I will simply perform this logic. And while extracting, I will count number of digits. And finally, I will print my output, that was number of digits, right? Okay, now let's write the code for it. So let me keep a comment first. Program to count number of digits. N equal to int of input of enter a number, right? Later, I will use a while loop. So what is my terminating condition? If you observe, we will continue these iterations till my quotient will become 0, right? So once my n will become 0, I will stop my iterations, right? There is no need to go further. So this will act as my terminating condition. So in the while loop, I will keep if n not equal to 0, if my n is not equal to 0, then I need to perform the action, right? So what is my action? So that was reminder equal to n mod 10. And once I found out my reminder, my first iteration was completed, right? So I need to count that iteration, right? So to count that, I will take a variable. So, and I will initialize it as 0. So I will count that iteration by count plus equal to 1, which is similar to count equal to count plus 1. And then what I need to do? I need to make my previous iteration quotient as n, right? So to find out the quotient, what we will do? We will do n by 10. And we need to make it as n, right? N equal to n by 10. So we will use a float division to get the precise value in Python, right? Okay, let's trace this code. So initially my n was 123, right? I will check, is 123 is not equal to 0? Yes, it's true. Then my remainder will become 3, right? And my count will become 0 plus 1, which is 1. And then my n will become 12, right? And in the second iteration, I will check, is 12 is not equal to 0? Yes, it's true. Then my remainder will become 2. And my count equal to count plus 1, right? 1 plus 1, which is equal to 2. And my n will become 1. And in the third iteration, I will check, is 1 is not equal to 0? Yes, it's true, right? Then my remainder will become 1. And my count will become 2 plus 1, which is equal to 3. And my n will become 0. And in the fourth iteration, I will check, is my 0 not equal to 0? Which is false, right? Then I need to come out of the loop. Finally, we need to print the output. Print number of digits in n is count. And one more thing, if I keep n here, then in the output, then I will get number of digits in 0 is. Because after completion of all this iteration, my n was becoming 0, right? So I was losing my value of n. So in order to restore it, let's restore that value in some variable, some new variable. My new variable was num and I was restoring n, right? So I will keep num here. So this is the program, guys. Now let's run this program. So I will give 123. So if you see, the number of digits in 123 is 3, right? Let me run this program again. This time I will give. So the number of digits in this number is 9, right? Let me run this program again. 5648. So the number of digits in 5648 is 4. Simple. So in this way, we will write a program to count number of digits in a number, guys. In this video, we are going to discuss about a program that was reverse of a number. So what is the reverse of a number? If n equal to 123, then the output should be like 321. So if my n was 123, then I need to print in the reverse order. That was 321. That's it. And if n equal to 92,538, then my output should be like 83,529. And if n equal to 1000, the reverse of 1000 was 1. So now we need to write a code for this reverse of a number. So what we are doing? We have a number 123 and we need to convert this to 321. So we need to print the reverse number, right? So for that, what we need to do? My first step was we need to extract all the digits of the number. So if I extract the digits, we got 1, 2, and 3 individually, right? Later, what we need to do? We need to append all these to a variable, right? How we need to append? We need to append them in a reverse format, right? So this is what we need to do now. So first we need to extract the digits, right? How we can extract the digits? So for that we have a logic. So what is my number? My number was 123, right? Keep 123. Okay. While we are extracting, we can extract the last digit very easily. How? If we do n mod 10, then we can simply get the last digit. So this is nothing but 123 mod 10. Right, let's do that. So 10 and 123. So 10 12s are 120. Now my remainder was 3, right? So if you see, I got my last digit. Now we need to extract the second last digit, nothing but 2. How we can get that? So if you observe the quotient, that was 12, which is the remaining part, right? So we need to do quotient mod 10, nothing but 12 mod 10. So if we do it, so this was 10 and 12. So 10 ones are 10. And my remainder was 2, right? So this is what the last digit, right? And we need to extract the third last digit, nothing but 1, right? And if you observe, my quotient was 1, which is the remaining part. We need to do 1 mod 10, right? So this is 10 and this is 1. So 10 zeros are 0 and my remainder was 1. So if you see, my remainder was the last digit. So in this way, we will extract the digits. And one more thing, to get the last digit, my n equal to 123. And to get the second last digit, my n will become 12. And to get the third last digit, my n will become 1. So by this, we can say, to get the reminders, we need to do n mod 10, right? To get the quotient, we need to do n by 10. Fine. Okay, now the first part was completed. That was extracting the digits. So next, what we need to do? We need to append all these digits to a variable in the reverse format. And if you observe, we already extracted the digits in the reverse format. At first, we extracted the last digit and then the second last digit and then the third last digit, right? So now we need to append all these numbers to a variable, right? Let me take a variable a and initialize it as 0. Initially, my a was holding a value of 0. There is nothing in it. And later, what I need to do? I need to append the last digit. That was 3, right? Now my a will become 3. And then I need to append second last digit. Then my a will become 32. And then third last digit. Then my a will become 321. Now this is what we want, right? So now how do we need to achieve this? Let's figure it out. We can also write this 3 as 0 plus 3, right? And this 32 as 30 plus 2. And this 321 as 320 plus 1, right? So what I was doing here? I just doing 3 into 10 plus 2, right? And here I was doing 32 into 10 plus 1. And here 0 into 10 plus 3. So what is this 3, this 2 and 1? These are reminders, right? Okay, fine. What is this 0 and this 3 and this 32? These are the previous A values, right? So let us say this is the step 1 and this is the step 2 and this is the step 3 and this is the step 4. This is my previous A value, right? That was the step 1 A value. If you see this, this is my previous A value. That was A equal to 3, right? And this 32 is also the previous A value, which is equal to 32. And this 10 is every time we are multiplying with the previous A value, right? Now, so by this, we can get a formula. The formula was A equal to A into 10 plus remainder, right? This is what the formula. So using this formula, we will append all the digits to this variable. So now we need to write the code for it. So before diving into the coding part, let's figure out the logic in simple words. At first, we need to take the input, and my input was n, right? And coming to the logic part, here we are iterating on each and every digit in the number. So we need to use a while loop. And while iterating on the number, we need to extract the digits and we need to append to a variable using this formula, right? And later we need to print the output, nothing but A, right? So let's write a code for it. So let me keep a comment first. That was reverse of a number program, right? At first we have to take the input, right? N equal to int of input of enter a number. Later we need to use a while loop, right? Let's think for the condition later. Let's focus on the logic. So what is my first step? I need to extract the digits, right? How we can extract the digits? By doing n mod 10, right? Okay, let's do that. I will do n mod 10 and I will store it in a variable. Let us say I was using a variable that was rem. And later, using these digits, what I need to do? I need to append to a variable, right? That was A. And I initialize my A to 0. I will do A equal to 0 at first. And I will use the formula A equal to A into 10 plus remainder, right? So is this enough? No, right? We need to go for the next iteration. So if we want to go for the next iteration, what we need to do? We need to find out the quotient also, right? Okay, let's do that. So how we can find out the quotient? We will do n by 10, right? So we will use floor division to get the precise value. And after that, what we need to do? We need to make this quotient as n, right? So n equal to quotient. So instead of taking an extra variable like quotient, let's simply write n equal to n by 10. So now let's trace the code. Initially, my A was 123, right? And in the first iteration, my remainder will be 3. And I was doing A equal to A into 10, nothing but 0 into 10 plus 3, which is equal to 3, right? And then my n will become n by 10, nothing but 12. And in the second iteration, my remainder will become 2. And I will do A equal to A into 10, nothing but 3 into 10 plus remainder, that was 2, which is equal to 32, right? And then my n will become 1. And my remainder will become 1. And my A will become 32 into 10 plus remainder, which is equal to 320, right? And then my n will become 1 by 10, which is equal to 0. So if you observe, when we reach the last digit, then we will get n equal to 0, right? Even if you see, my quotient was 0, right? And in the fourth iteration, my n will become 0, right? So this condition will represent to stop me the iterations, right? When my n will become 0, then I need to stop iterating on the while loop. So my while condition was n not equal to 0. Because when my n not equal to 0, then I need to follow these steps. Once my n will become 0, I need to come out of the loop, right? So that's why I kept n not equal to 0 as my condition. So this is the logic part. We need to print the output, right? Okay, let's print that. Print reverse of the number equal to comma A, right? Okay, this is the code, guys. Now let's run this program. I will give 123. So if you see, the reverse of the number is 321, right? This time let's give 92,538. Okay, let me run this program again. I will give 92,538. So the reverse of the number was 83,529, right? Okay, let's run this program again. So this time I will give 1000. So the reverse of the number was 1. So now I want to change my print statement, like reverse of the number n is a. Okay, let me do this now. So I will give 456. So if you see, the reverse of the number 0 is 654. My n value was 0. Because after completing all these iterations, my n will become 0. That's why I was getting 0 in the output statement, right? So what we need to do to achieve the actual number? Simply we need to restore it, right? Restore it before the logic. So this is my logic, right? So we need to restore it before the logic. I will restore it in a variable that was num equal to n, right? Now here we need to keep num. Okay, now let's run this program. So I will give 456. So if you see, the reverse of the number 456 is 654. Fine. Now let's run this program again. So I will give a big number. So if you see, the reverse of the number is in the reverse order. And let me run this program again. So this time I will give 001023. So if you see, the reverse of the number 1023 is 3201. So this is the standard way of writing a code for reverse of a number, guys. In this video, we are going to write a program to check whether a number is a palindrome number or not. So what is a palindrome number? A palindrome number is a number that remains the same when its digits are reversed. In other words, if you read the number from left to right or right to left, it will be the same number. For example, 121. If you read this number 121, in the forward direction, it was 121. Even if you read the same number in backward direction, it is same, right? That was 121. And also if you see this example, if we read this number forward, that was 1331. And if you read the same number backwards, again it was 1331, right? And also 1221. These numbers are called as palindrome numbers because they read the same forwards and backwards. So now we need to write the code for it. Simple. So before diving into the coding part, we need to think for the logic, right? My logic was very simple. Let us say my number was A, and what I need to do? I need to reverse this number, right? I will do reverse of A. Let us say this was B equal to reverse of A. After reversing A, I need to check, is my A equal to B or not? If it is equal, then I will say A is a palindrome, right? And if A and B are not equal, then I will say not palindrome. Simple. We can implement this last two steps using an if else, right? Now our main focus is to reversing a number. In the previous video, I have already discussed about how to reverse a number. If you haven't watched that video yet, please do watch it. I will provide the link in the description box, so please do check it. And in this video also, I will explain the logic of how to reverse a number. Okay, let's see that. Reversing a number is very simple. So we have only two steps to reverse a number. So at first, we need to extract all the digits from the number. Extracting the digits. And later, we need to append all these digits to a variable, a new variable in reverse format. So this is the logic. So now the question was how we can extract the digits. It is simple. Suppose if we have a number n equal to 131, we can extract the last digit very easily. I will do n mod 10. Okay, let's do that. 10 and 131. Right. So we know 10 13s are 130. Right. So the remainder was 1. We got the last digit, right? Now we need to get the second last digit, which is 3. Now if you observe, my quotient was 13 when I do 131 divided by 10, right? So this is nothing but the remaining part. So now to get the second last digit, we need to do 13 mod 10. If we do this, so we know 10 ones are 10. And now my remainder was 3, right? Now we got the second last digit also, right? And if you see the quotient, that was the remaining number, right? And now to get the third last digit, what we need to do? We need to take this quotient and we need to do 1 mod 10, right? If we do this, so 10 zeros are 0 and my remainder was 1, right? And if you see, I got the third last digit also. So in this way, we will extract the digits. So for the reminders, we will do n mod 10, and for the quotient, we will do n by 10, right? And one more thing, to get the first last digit, my n equal to 131. And to get the second last digit, my n will become 13, nothing but the quotient, right? And to get the third last digit, my n will become 1, nothing but the previous quotient. And one more thing, if you observe, we are extracting all these digits in the reverse format already, right? We are extracting the last digit first, and then the second last digit, and then the third last digit, right? So we are already extracting the digits in the reverse format, right? So in this way, we'll extract the digits. And next, the second step was we need to append all these digits to a variable, that too in a reverse format. So let's take a variable. Let my variable was a, and I will initialize it to 0. Initially, my a will store nothing. So that's why I kept 0. And in the second step, what I need to make? I need to append my last digit, right? Then my a will become 0 plus 1, which is equal to 1, right? And then I need to append my second last digit. Then my a will become 13. And then my third last digit. Then my a will become 131. And one more thing, we can write this 13 as 10 plus 3, right? And this 131 as 130 plus 1, right? And this one as 0 plus 1. And we can also write the same numbers like 1 into 10 plus 3, right? And this has 13 into 10 plus 1, right? And this has 0 into 10 plus 1, right? So now, what are this 1, 3, 1? These are my reminders, right? And what are this 0 and then 1 and 13? These are my previous a values. Okay, let's make, this is the first step, and this is the second step, and this is the third step, and this is the fourth step. Okay, if you see this step, this one is coming from the previous a value, that was a equal to 1, right? And if you see the step 4, this 13 is coming from the previous a value, that was a equal to 13, right? And also in the step 2, this 0 is coming from the previous a value, that was 0, right? And every time we are multiplying 10 to its previous a value, and we are adding the remainder. So by this we got the formula, right? The formula for reversing a number was a equal to a into 10 plus remainder. So this is the formula for reversing the number. So how we are appending all these digits to a number? Using this formula, we need to append all these digits to a variable. Okay, in this way, we will reverse the number. So now we need to write the code for it. So before diving into the coding part, let's figure out the logic in simple words. At first, we need to take the input. So what is my input? My input was simple, that was n. And then the logic part. So what we are doing, we are iterating on each and every digit of the number, right? So for the iteration, we will use a loop, that was while loop. And while iterating on the number, we need to implement these two steps, that was extracting the digits, and we need to append all these digits to a variable, that was a. So after completing the iterations on while loop, the number will be reversed, right? So then what we need to do? We need to check whether my number is a palindrome number or not. For that, we need to use an if-else statement. And we need to print if it is a palindrome or else not a palindrome. So now let's write the code for it. So let me keep a comment first. Check if a number is a palindrome number. Right? Okay. At first we have to take the input. N equal to int of input of enter a number, right? So I need to iterate on the number, right? So that's why I will use a while loop. So let's think for the while condition later. So what I was doing, I was extracting the numbers. How we can extract the numbers? Using n mod 10, right? Okay, let's do that. I will do n mod 10 and I will store it in a variable that was rem equal to. After extracting the digit, we need to append all these digits to a variable, right? That was a. So at first, my a was initialized to 0, right? So then I will use this formula a equal to a into 10 plus reminder, right? Is this enough? No, right? In the first iteration, to get the last digit, my n was 131. And in the second iteration, to get the second last digit, my n was 13. And to get the third last digit, my n was 1, right? So what I need to do? I need to make n equal to n by 10, right? I will do that. N equal to n by 10. I will use a float division to get the precise value. So now coming to the condition of the while statement, where do I need to stop my iteration? So if you observe, this is the first last digit and this is the second last digit and this is the third last digit, right? And I will stop my iteration when my quotient will become 0. Nothing but in the next iteration, my n will be 0, right? So once my n will become 0, I need to stop my iteration. So this is the base condition, right? So my while loop condition was n not equal to 0 because I need to iterate on the loop when my n is not equal to 0. Once my n will become 0, I need to stop the iteration. So what I need to check? I need to check whether my number is a palindrome number or not, right? Now my reverse of a number was a. I will use an if statement, right? Now what I need to compare? I need to compare my a and also the user given number, right? I will compare is a equal to n. So if you do compare this, it will become a blender mistake, guys, because so after completing of the iterations, my n will store 0. So for that, what we need to do? It's very simple. Just restore the number. So num equal to n. So I will check if a equal to num, then I will print num is a palindrome number, right? Or else I will print num is not a palindrome number. So this is the code, guys. Now let me run this program. So I will give 131. So if you see 131 is a palindrome number, fine. Let me run this program again. I will enter 123. This is not a palindrome number, right? If you reverse this 123, then I will get 321. So if you see 123 is not a palindrome number. Okay, fine. Let me run this program again. I will give 134331. So it is a palindrome number. Fine. And let me run this program again. 67894 6. So this is not a palindrome number, right? So this is the standard way of writing a program to check whether a number is a palindrome number or not, guys. In this video, we are going to discuss a program to convert a decimal number to a binary number. So let's see the binary conversion of a decimal number 11. So what we will do usually, if we want to find out a binary conversion of any decimal number, we will divide that decimal number with 2, right? So let's do that. It was 11. So the quotient was 5, right? 2 5s are 10 and the remainder was 1. Okay. And I will again take this quotient and I will again divide this quotient with 2. 2 2s are 4. And again my remainder was 1, right? And I will again take this quotient and divide it with 2. 2 ones are 2 and this time my remainder was 0, right? And I will again take this quotient and divide this with 2. 2 zeros are 0 and my remainder was 1. I will do this process until my quotient will become 0. And if you see now my quotient has become 0. So I need to stop my calculation. Okay. Now we need to consider from the backwards. That was binary of 11, we need to consider from backwards, right? So that was 1011. So 1011. So this is the binary of 11. Okay, let's check whether it's correct or not. In Python, we can use a binoff function. This is the predefined built-in function. And we just need to define the decimal number within this binoff. And if you see, it was 1011. So, and we got 1011 only. So in this way, we will find out the binary of any number. But this method is not a standard way of finding out the decimal conversion of a binary number. So we need to think for the standard approach. The standard approach is very simple. If you see what we are doing, we are thoroughly dividing our number with 2, right? Till my quotient will become 0. So what we are doing? To find out the reminders, we will do n mod 2. And to find out the quotient, we will do n by 2, right? And finally, what we need to do? We need to arrange these reminders in the reverse order, right? In the backward direction. Okay, let's see the logic to how to arrange these reminders in the reverse order. So how we want our binary number? We want it as 1 0 1 1, right? Okay, instead of consider this number as a binary number, let's consider this as a decimal number. If we consider this number as a decimal number, we know this 1 is at the first place, right? And this 1 is at the 10th place, right? And this 0 is at the 100th place, right? And this 1 is at the 1000th place, right? And one more thing, this is the first iteration reminder where we place this at first place, right? And this is the second iteration reminder where we place it at 10th place, right? And this is the third iteration reminder where we place it at 100th place. And this is the fourth iteration reminder which we place it at 1000th place, right? So what are your observations? We need to go in the forward direction only, which means we need to find out the reminders in the forward direction only. And while we are finding out the reminder, we need to place them in backward direction, right? Nothing but we need to keep them in their appropriate places, right? If we get the first reminder, we need to keep it at first place. And if we get the second reminder, we need to keep it at the 10th place. And then the 100th place. And then 1000th place. So how to achieve this? It is very simple. How we can write this 1011? We can write it as 1 into 1000 plus 0 into 100 plus 1 into 10 plus 1 into 1, right? We can write the same 1011 as like this, right? So if you observe, this is my first reminder and this is my second reminder, this is my third reminder and there's a fourth reminder, right? And these are my places. This is the first place, 10th place, 100th place, 1000th place, right? So what we are doing, every time we are multiplying our reminders with their places and we are adding them, right? That's it. So simple. So at first we do n mod 2, right? Let us say initially my place was 1. Every time my place will be 1, right? So what we are doing? We are doing place into reminder, right? And we need to store this in some variable. And finally what we are doing? We are appending all these results, right? So for that, let's take a variable, answer variable, and initialize it as 0. And let's append all these results to an answer variable. Simple. And later what we are doing? We are making the quotient as n, right? So how we can find out the quotient? We can find out by n by 2, right? So, and we are making it as n equal to n by 2. And also one more thing, if you observe, in the first iteration my place was 1, and in the second iteration my place was 10, and in the third iteration my place was 100. So every time it was changing. How it was changing? It was changing place equal to place into 10, right? Every time it was multiplying by 10. So we need to change our place also. So this is the logic, guys. So now we need to write the code for it. So before diving into the coding part, let's figure out the logic in simple words. At first, we need to take the input. The input was simple. That was a decimal number, right? N. And then coming to the logic part, we need to implement this logic in our code. So for that, I will use a while loop. And finally, I will print the binary conversion of that decimal number, right? Okay, let's write that. So let me keep a comment first. Program to convert decimal to binary, right? So let's take the input first. N equal to int of input of enter decimal number, right? And later what we need to do? I need to use a while loop, right? So what is my while condition? Where should I need to go till? I need to go till my n is not equal to 0, right? Once my n will become 0, then I need to stop my iteration. So this is the terminating condition, right? So my condition was n not equal to 0. What we are doing? We are finding out the remainder, right? Remainder equal to n mod 2. And now what we are doing? We are computing place into remainder and appending that value to answer variable, right? So for that, what we need to declare? We need to declare our place and answer variables, and we need to initialize the place as 1 and answer as 0, right? Let's do that. So place equal to 1 and answer equal to 0, right? And then answer equal to answer plus place into remainder. Later, what we need to do? We are making the previous iteration quotient as n, right? So let's do n equal to n by 2. We will use the float division in Python to get the precise value. And later what we are doing? We need to change our place variable, right? How? Place equal to place into 10, right? So this is the logic part. Now let's print the output. Print the binary conversion of n. So if I keep n here, then in my output, I will get like the binary conversion of 0 is because once my n will become 0, I was coming out of the loop, right? So I was losing my value of n. But we can restore the value of n by simply storing it in some another variable. Let us say num variable. So I will keep here num is answer. Simple. Okay, now let's run this program. So I will give 11. So the binary conversion of 11 is 1011, right? Let's run this program again. So this time I will give 5. So the binary conversion of 5 is 101, right? And let me run this program. I will give 20. So the binary conversion of 20 is 10100. So in this way, we will write a program to convert a decimal number to binary number, guys. In this video, we are going to discuss about a program to convert a binary number to a decimal number. So let us take an example of decimal conversion of the binary number 1011, which was 11. But how we will compute the decimal conversion of any number to a binary format? Okay, let's take this 1011. So this was 1, 0, 1, and 1, right? So this is the 0th bit, and this is the first bit, and this is the second bit, and this is the third bit, right? Usually to convert this binary number to a decimal number, what we will do is we will multiply this bit with 2th power of their bit position. So if you see, this is the bit number and the position of this bit was 0th bit, right? So that's why we did 2th power of 0 and the next bit. And this is the bit number 1 and the position of this bit number 1 is at first place, right? So that's why we did 2 power 1. And this is the 0th bit and we did 2 square, right? And this is the bit number 1 and we did 2 cube because it was at third bit, right? So in this way, we will convert the decimal conversion of a binary number. Simple. Now we need to write a code for it. So before that, let's figure out the logic. My logic was very simple. We just need to convert this calculation into a code format. That's it. If you observe, these are the bit numbers. This is bit 1, bit 0, and bit 1, bit 1, right? So what we need to do? We need to extract these bit numbers, right? We need to extract them individually. We need to separate them. After extracting, we can easily multiply with 2th power of their bit positions, right? So now the question was how we can extract these bits. So for that, instead of considering 1011 as a binary number, consider it as a decimal number. So let's say this is the decimal number. Let's take n equal to 1011, right? So to extract the digits from that number, let's perform n mod 10. So if we do this 10 and then 1 0 1 1, right? So 1 10 1 0 1 0 1 0 1 0, right? And my remainder was 1. This is the 0th bit. This is nothing but the 0th bit. And if you observe the quotient, which is the remaining part, right? Again, take this quotient and do 10 mod 101. So if you do 10 tens are 100, right? And my remainder was 1. And if you see, this is the first bit. And if you observe the quotient, which is the remaining number, right? Now let's again take this 10 and just perform 10 mod 10. So 10 ones are 10 and my remainder was 0, which is the second bit, right? And if you observe the quotient, which is the remaining number, right? Now again perform 1 mod 10. So 10 zeros are 0 and my remainder was 1. Now we got the third bit also. And if you observe, once all the bits are extracted, then my n will become 0. So in this way, we can extract the bits from the number. So let's write down the logic first. So we are doing n mod 10 to get the bit, right? And once we got the bit, what we need to do? We need to multiply our bit with the bit position, right? Initially, the position of the bit was 0. So I will do bit into 2 power of position, right? And after computing this, what should I need to do? I need to preserve it by adding it with some another variable. Okay, let's take a variable that was answer variable and initialize it with 0. And I will do answer plus equal to this result. I need to increment by position, right? So in the first iteration, my position was 0 and in the second iteration, my position will become 1 and then 2 and then 3, right? So that's why I incremented by position. And also one more thing, in the first iteration, my n was 1011 and in the second iteration, I was considering my previous iteration quotient as n, right? And in the third iteration, my n was 10, right? The previous iteration quotient and this is my n. So I need to perform n by 10 and I need to make it as n equal to n by 10. So this is the logic, guys. So now we need to write a code for it. So before diving into the coding part, let's figure out the logic in simple words. At first, we need to take the input, right? The input was this binary number. Later, we need to apply this logic. So for that, I will use a while loop, right? And then finally, I will print the output that was the answer variable, right? Simple. Now let's write the code for it. So let me keep a comment first. Program to convert binary to decimal. Now we need to take the input n equal to int of input of enter binary number, right? And then I will use a while loop. So what is my while condition? Where should I need to go till? I need to go till my n will become 0. Once my n will become 0, then I need to stop my iterations, right? So this n equal to 0 will act as a terminating condition. So I will check if n not equal to 0, I need to perform an action. So what is my action? So this is what we need to perform, right? So at first, I will do bit equal to n mod 10. And later what we are doing? We are performing this, right? For that, we need to initialize our position and answer variable as 0, right? Okay, let's do that. So position equal to 0 and answer equal to 0. So I will do answer equal to answer plus bit into 2th power of position. Later, what we are doing? We are incrementing our position, right? So position plus equal to 1. And then we need to make our previous quotient as n. So I will use the float division to get the precise value in Python, right? So this is the logic, guys. Now let's print the output finally. So print the decimal conversion of n is answer, right? And if I keep n here, then my output will be like the decimal conversion of 0 is, because after completion of all these iterations, my n will become 0, right? How can I restore it? Simple. Just store it in some another variable, num equal to n. And here, keep num. Simple. So this is the code, guys. Now let's run this program. So I will give 1011. So if you see, the decimal conversion of 1011 is 11. Fine. Let me run this program again. I will give 101. Let's consider only bit number 1 positions. So this was 2 power 0 and this was 2 square, right? So 2 power 0 plus 2 square, which is equal to 5, right? So the decimal conversion of 101 is 5. Simple. Now let's again run this program. 1010110. So that was 86. So in this way, we will write a program to convert a binary number to a decimal number, guys. I hope you like this video and thank you for watching. Hey folks, if you enjoyed this coding tutorial and found it helpful, don't forget to give it a thumbs up. Share it with your fellow coding buddies, drop a comment with your thoughts or questions, and of course, hit that subscribe button and ring the notification bell so you never miss out on our latest content. Your support means a lot and it helps our community grow. Happy coding!